Yeah. I probably actually am going to take it off since I'm recording so you can hear me better on the recording. Okay, so we started inverses yesterday. We're going to review. We're going to review some before we go on. So we're going to find inverses and verify inverses, and we're going to start with verifying and using our composition of functions. So we talked about for them to be inverses, we have to do f and inverse of x, and it has to equal x. Now, if the variable is t, then it equals t. It doesn't automatically turn into an x. Everyone understand that?
Yeah.
Okay. And then I also have to do f inverse of f of x. That is just the same as we did the other day, going g of f of x and f of x of g. Exactly what we did the other day with our compositions of functions. The name just happens to be f and f inverse. Okay? So, inverses switch domain and ranges. So the domain of x in the range, the f inverse is the range of the domain. See that? The picture showed that clearly enough. And they physically just take and switch places. So if I gave you an x and y table, x is domain, yes?
Right.
Range is y. And I said, okay, this is f of x. So f inverse of x, they pick up places and move. So it would be negative 7, 6, 5, 1, 3, 6. And this is domain and this is range. The domain of f became the range of f inverse. Do you see that?
Yeah.
That is actually what happens, guys. So if I gave you the graph of f, you could give me the graph of f inverse by taking your x's and y's and swapping them. That's it. That's what inverses do. They completely undo each other. And that is why when I take f inverse and f inverse of x and I simplify them, I just get x. The diagram to me sometimes confuses me, but other people like it. I like the table. The table to me makes it all clear. I have other people that see the I always want to call it a Venn diagram, but it's not. But, oh yeah, it is. It doesn't have to touch. They like that because they have the arrows, and I just get lost in all that. It takes one, the domain of f becomes the range of f inverse. The range of f becomes the domain. Am I good? Okay, so we were in the middle of this problem yesterday, and it says which function is an inverse of f of x. So we needed to do f of g of x, and it had to equal x if it was the inverse, yes? But we would also had to have done what? G of f of x, and it equals x. You can't just stop at one of them, because composition of functions are not commutative unless they're inverses of each other. So we could get one to be equal to x, but you have to show that commutativity law. So I'm going to go through this. You already have it written down. I'm going to go through the f of g of x. Okay, so watch and don't be writing because you should already have it written down, correct? Okay, so if I'm doing f of g of x, I have 5 over x minus 2 over 5 minus 2. Okay? We do need to get over our fear of fractions because you're going to have lots of them and you need to be able to deal with them accurately and fairly quickly. I need to get common denominators in the denominator, and that is going to be 5. So this is 2 over 1, so that becomes 10 over 5. So I have 5 over x minus 2 minus 10 would be minus 12 all over 5. I divide in fractions. You notice this bar is bigger than this bar, so I know where is the numerator, where is the denominator. I'm multiplying by the reciprocal of the denominator, so I have 5 times 5 over x minus 12.
I don't get how you get that.
I reciprocated this.
So you just took the 5 off.
This,
you took the 5 on the bottom?
I took this is my whole denominator right here, and I reciprocated it. This.
Oh, okay. I see what you just did.
Okay. Now this, what is this 5? Is that 5 in the numerator or denominator? Numerator. So if it was in the denominator, I could reduce, yes? But I can't. So I now have 25 over x minus 12. And it's all reduced. What was that supposed to equal? X. Did it? No. So we're going to just, if I had a lot of time, if I go to h and it doesn't work either, I probably should come back and check my work, right? But I have an option to move to h, so I'm going to move to h now. So now I need to do f of h of x and h of f of x, right? And what should they both equal? X. Okay, so I have 5 over, now, I don't like this right here, but it will be nice. You could get common denominators before I even started, yes? Do you see that? But I just stopped because look what's going to happen. I'm going to plug this into here, and what's going to happen with my 2 and my negative 2? They're going to zero out, right? So I don't have to get common denominators. If they weren't going to get zeroed out, I probably would go ahead and just get common denominators when I start plugging it in. So looking ahead does help. So I have 5 over x plus 2 minus 2. So my 2 and 2 zero out, so I have 5 over x. I now multiply by the reciprocal. So I have 5 times x over 5. My 5's reduced, and I have a x.
Okay.
Okay? So f of h worked. Now I need to make what work? H of x. Yes. Okay. I will post this video on the new one. Only one person subscribes. Hey, that's me. Okay. So I gotta put f now into here, correct?
Yeah.
So I have 5 over x. Oh yeah, whatever. I'm writing it correctly, saying it wrong. Plus 2. So I plug this whole thing in here. So I don't want to get a common denominator of 5 over x minus 2. Do you? No. So what I can do is I can look at this as one piece, deal with it, and then add 2 when I'm done. Okay?
So you did over here?
So I'm going to do, what do I have to do over here? Multiply by the reciprocal. When I reciprocate this, what's going to happen to my 5's? They're going to reduce out. We're going to use those big words, right? And then it's going to reduce out, and I'm going to get x minus 2 plus 2, which is what? X. If these are inverses of each other, should they just kind of fall apart? Yes. They should just kind of fall apart, and everything should start reducing and get you down to where it needs to be fairly easy, even though it looks gross.
So the answer is?
This whole thing is my answer.
Okay.
Because I says, which one is inverse? So I guess h of x is the inverse of f of x. But we had to verify that by doing h of f of x of h. Make sense?
What is the whole right side of what we just did? Or what? Because we already got the x from the
right, but we have to do both. The first time we did h of f of h, and then we need to do h of f. This right here is the h of f. Yeah, you have to do both.
Did we do that for the first one?
No, because we figured out the first
Yeah,
one.
Yeah, the first one didn't come out to be x, so there was no reason to keep going.
How do you?
think I'm getting confused only because of all the fives.
Right. And hopefully on your paper they're more spread out than on here. My board gets really, once I turn on the projector, my screen gets really teeny.
You just said something about connection also.
Hopefully it was just my mouse.
I think it was.
Okay.
I'm just,
Was it a picture of the mouse?
it looked like I just saw connection.
Yeah, if that was the mouse, it shuts off when you're not using it. So, we're gonna do more.
Wait, oh, sorry.
Okay, so show that. Show, verify, improve. Show, verify, improve all mean the same thing. Okay, it all means to prove it. And to prove it, I have to do f of f inverse equals x and f inverse of f equals x. I have to do both. I'm stressing that because I always have people that say, well, I did it once, I don't have to do it again. You have to prove, you have to do it mathematically, and you have to prove that commutativity of the composition because it doesn't happen unless they're inverses. So, how are we going to prove or show that they are inverses algebraically? You don't know graphically yet. Yes?
Take f of x and we'll put g of x and f of x.
So we're going to do f of x. Oh, sorry. I said what you said. I wrote what you said, but then you corrected yourself. So we're going to do f of g of x. And what does it have to equal? X. Now again, if that variable was h, what would it equal? If it was f of h equals h minus 5, it wouldn't equal x, it would equal what? H. And then we also have to do what?
G of f of x.
And it's going to have to equal what?
X.
X. So, f of g of x. So, let's see, x plus 5 minus 5. I think that equals x pretty easily, doesn't it, don't you?
Yep.
The other one's going to fall apart really easy too, right? I started you off with a really ugly one. They're not always that ugly, and they're not always this easy. They're kind of in the middle.
Okay, I'm
So g of f of x, sometimes they're really ugly. So let's
x
see.
minus 5 plus
X minus 5.
Sometimes when I write it like that, or like on the f and g of x,
Mm-hmm.
when I write the parentheses around x plus 5 and then in parentheses negative minus 5, I think of it as times negative 5, and it confuses me.
It would be times negative 5 if the negative 5 was in parentheses.
Okay.
Does that make sense?
Yeah.
Because if it was like this, it would be multiplication.
Yeah.
But the negative's in between there. The biggest reason I do that is because if you do have a negative, we've got to remember to distribute. And if we don't put that parentheses in there, we tend to forget to.
Yeah.
So now it says graphically. Now what did I say happened with inverses? What happens graphically? What things?
They just
The
switch.
x and y.
X and Y's just physically switch places, yes? Okay, so we gotta graph that. And these are two equations we know how to graph, yes?
Yeah.
Okay. Okay, so this one, f of x, has an x-intercept of negative 5.
Yeah.
And it has a y-intercept of what?
0.
No, if I was y-intercept, I plug a 0 in for x, and I still get what?
Negative 5.
Negative 5. No, that's wrong. Why would that be wrong? What way would this line go? It would go down. Oh, I did the y-intercept twice. The x-intercept, set it equal to 0. So what would x equal? 5. Do you see why I said that was wrong?
Yeah.
Because this line would have been going down, and this line should be going what?
Uh,
Up, because the slope is positive. So just because you do something, you should think while you're doing it, right? Because sometimes I did the y-intercept twice. Okay, 1, 2, 3, 4, 5. Okay, so this line goes like this. Yes? Okay. So this is f of x. And g of x, what's your y-intercept?
Negative. No, 5.
5. What is your x-intercept? Negative 5. And that's good because, right,
Still going.
it's still going up. And these two lines are what to each other?
Parallel.
How do we know that?
Because they're
Because they look like it?
They'll
No.
never run in.
Look at the equations. Why do we know that?
They're inverse.
They're in.
No.
Because they have 1 plus 1 negative.
What do parallel lines have the same of?
Slope.
Slope.
Slope is the same.
The slope is the same, right? So those are parallel. Okay, now, well, that really didn't do a whole lot of good, but we said x's and y should be switched, yes? Yes, Riley.
How do you find the x-intercept?
You set it equal to y, or set it equal to 0 and solve. So I'd subtract one.
Oh, okay.
Every x-intercept, no matter what the equation, no matter how simple, how extravagant, you set it equal to 0, set y is equal to 0 and solve. Okay, so this point right here is 0, 5, yes?
Yeah.
Okay, so if this is g of x, and I'm going to tell you guys, these are inverses of each other. Does that make sense? If I call g of x f of x, then f of x is f inverse. They're inverses of each other. So this is 0, 5. What point better be on this one?
5.
5, 0. Is it?
Yeah.
Okay. This right here is negative 5, 0. So what point better be over here?
0, negative 5.
0, negative 5. So those were like really simple ones. Let's see if we can do another one. Like, what happens if I have negative 1? Okay, so this point. If I have negative 1, and don't use the graph, use the equation. Okay, so if I plug negative 1 into g of x, I get what?
For X or for 5?
If you plug it in.
If I plug
Four.
negative 1 in,
A positive 4.
I get 4. So that means what point better be on here? 4, negative 1. So that would be, yeah, my graph is a graph. It's a sketch, right? So let's see. So if I plug in 4 to f, what do I get? Negative 1.
What?
Okay.
No way.
Every point I choose, is that going to work? Every time.
Yeah.
Yeah.
If it's an inverse.
Yeah.
Okay.
If you're
The
right.
other thing is it reflects across the identity line. The y equals x line. So y equals x. What's the slope of that? 1. What's the y-intercept of that? 0. So it's this. Now, when this is really bad. When both of my functions have a slope of 1, right? And they're both linear, do you see a whole lot of reflection? No. But if they're not, we'll see some other ones later on that aren't, and you'll see that reflection in there, okay? But this imaginary line, so let's say if I had, let me get a different color. If I told you one graph looked like this, the other graph would look like this.
That's reflection.
Do you see the reflection?
Yeah.
Okay, that's what inverses do. Sometimes they'll cross over the line. See if I green show up. Sometimes they'll go like this, and then this one would go like this, and they always meet on that y equal. Their intersection is always on that y equals x line. So inverses, if it says to graph it and verify it, you're going to put it in your calculator, and what should you see? You should see that reflection in there, okay? What I would suggest you do, if they said verify it through graphing, put it in your calculator, that's okay, okay? I would put F, I would put G, and then I would also put this line. Why would I put that line? And then
To show the
Y equals X
reflection.
every time?
you just put X, because it already is Y equals in your
Do you have to use
calculator.
that bars button?
We'll get, in a minute, we'll do like more
Well, that's when you
stuff.
add them.
Yep. This isn't really very exciting, so. Okay, so does a function have an inverse? Now, before you start writing everything, listen, because you don't need every word on this slide, okay? We're going to learn to take notes. You guys are writing every single thing, and that's not always the best. Okay, so does a function have an inverse? Every function has an inverse. The real question is its inverse also a function? Okay? The book will say, does it have an inverse? Then you'll say yes or no. But the real thing is its inverse also a function? Because I can think about it. If I have an equation, could I take all of its x and y coordinates and interchange them and graph something new? Yeah, there's nothing stopping me from doing that except a rational function. That's a fraction, right? And anytime it's 0, it'd be undefined. But that's the only thing that's stopping me. But the real question is its inverse also a function? Okay? The answer is yes if. If it is a function, yes, it passes the vertical line test. Remember? Functions pass the vertical line test. Does it pass the horizontal line test? And we talked about that when we did our parent function, so that sheet. The horizontal line test. If it was a horizontal line test, it is 1-to-1, and it means that the function, its inverse is also a function. So to look at a graph and say that has an inverse that is also a function is if it passes the vertical and horizontal line test.
Wait, what's the
What's
horizontal
the
line test
horizontal
again?
line?
A horizontal line, same as the vertical. Vertical
So,
means only once, right? Horizontal means only once. So if I came back here,
So what if you got one of those inverses?
okay, so I came back here, look at the red.
Yeah.
Does the red, we'll look at g of x, does it pass the vertical?
Yeah.
Yes. Does it pass the horizontal?
Yeah.
Yes. Now look at the blue. Does it pass the vertical?
Wait,
Yeah.
but they both go through two lines.
But it's like
But
each line only goes through one
Right.
step.
Okay.
Right.
Okay.
Look at them individually, okay? So the blue, does it pass the vertical?
No.
Yeah.
Yes.
No.
Yes.
Yeah. Yeah.
Yes. Because even though this looks like it's going to go straight up, it's not. It's going to...
Wait,
Okay,
it's gonna
vertical.
go straight-
Does the blue pass the vertical line test?
Wait,
Yeah.
if it curved, it would go through.
No.
Yeah.
Yes. Okay.
Oh,
Thank you.
cruising.
Is it going straight up?
No,
or
it's not. It's going... It's... To your eye, it looks like it's going straight up, but it will continually approach. It won't be completely vertical.
Yeah, that's what I mean. It's
So
gonna
it-
keep curving, so it will go through.
No.
Not unless it went completely vertical, which it won't.
No. As long as it does not go completely vertical, it will not fail the vertical line test. But
Okay, but it's gonna keep
It's-
curving.
like
and
it's
the
gonna-
line's
no,
gonna
no,
go
no,
through
no,
that.
no.
Yellow.
Okay, here's an imaginary vertical line, yes? This blue graph is going closer and closer and closer and closer and closer and closer, and we're talking infinity here.
I thought it was curving to the left.
No, it's not gonna
Yeah,
keep.
that's what it looks
No,
like.
that's just bad drawing, that's a sketch. Okay, that's a sketch. And yes, there are some that go back like that, but not what I drew. It's just a bad drawing, sorry. Okay, so does the blue pass the vertical line test?
Yeah.
Does it pass the horizontal line test? Yes. So its inverse is also a function. Okay, the green, does it pass the vertical line test?
Yes.
Yes. Does it pass the horizontal line test?
No.
It passes them both.
Good question.
Would it eventually
If
fail?
it does, okay, if it does go down like this, does it pass it?
No.
No. So it has an inverse, but is the inverse a function?
You know.
No. Okay? So that's the real question. So what I want you to know here is this. I want you to know if its inverse is also a function, it has to pass both the horizontal and vertical line test. In this book, it just says, does it have an inverse? And it should be, does it have an inverse that is a function? Does that make sense, what I'm telling you?
So like when it says, is this an inverse?
Does it have an inverse? You would
The
answer,
answer is if it's a function.
well, you have to say, does it pass the vertical and horizontal line test? Okay? And that is that 1-to-1. If it passes both the vertical and horizontal line test, it is 1-to-1. And that means every domain value x has exactly one range value, and that's a definition of a function, yes? Every x has exactly one y, but also every y has exactly, guess what? One x. So
So-
here,
If it passes the horizontal and vertical, it's a function.
Yeah.
the inverse is also a function. If it passes the vertical, what you're looking at itself is a function. But if it passes the horizontal, then its inverse is also a function. And I don't understand why textbooks do that. Because forever I thought, well, not every function has an inverse. Yeah, it does. Every function has an inverse. It's whether that inverse is also a function. That's the biggest question. We can restrict domains, and we will do that in the trig portion. We'll restrict domains. This is a sine wave. Okay, is that a function? Does it pass the vertical line test? Yes, it does. But is it pass the horizontal line test? No. Its inverse is not a function. Its inverse actually looks like this. Obviously not a function, correct? So we will take it and we will restrict it right here. So we only see this portion. Does that pass the horizontal line test? Yeah.
No.
Yep.
Oh yeah.
Because nothing repeats. I hit it here, but I stopped it right before there. Okay? So we can restrict it into chunks to make it have an inverse. And we'll do that in a trig. Yes?
So it can pass the horizontal line test, but not the vertical, and that would mean its inverse is just a function?
Yeah?
You find trig or PreCalc easier?
What?
You find trigonometry or PreCalc easier?
I don't know. I usually have students say they like trig. They think trig is easier, but it's probably because I tortured them all first semester and they know what to expect second semester. But I don't know. I have some people that like PreCalc better than trig. Just like how many of you like geometry better than you liked algebra 2 or algebra? So
I don't like it.
you don't like it either. Okay, are we good? Okay. So, right here. Is it a function?
Yes.
Yes. Why?
Vertical
Vertical line test. Is it, okay, I'll do the book's word. Does it have an inverse?
Yes.
No.
No.
Every function has an inverse.
Right, but the textbook is just going to say, does it have an inverse? But they want to say, is its inverse a function?
No.
Yes.
No.
Yeah.
No, because it does not pass.
Yes or no?
So,
horizontal
It
line.
doesn't pass.
It even has
Oh,
a dotted
yeah.
line.
Yeah.
When the textbook asks if it has an inverse, they actually mean is its inverse a function.
Right.
Okay,
They
I would.
say-
I don't
The
know
book should
why.
just say that.
That's.
But like I said, I think it's just implied. I think in general they just are implying it. Because why would we want to find something that's not a function, but it
So
does exist.
That's a function without an inverse.
Right. Without an inverse, that's a function. Yes.
So it's
Now-
not inverse, but its inverse is not a function.
Yes.
Okay.
Now, could I restrict this and make it have
You
an
cut it
inverse?
in half.
I could cut it in half, right?
Yeah.
So I could take it and I could restrict the domain to, what was on pen? I could say my domain was negative infinity to 0, right? If I did negative infinity to 0 and stopped right here, so you only saw the left side of this graph.
Now it is.
Now its inverse is a function. Could
Do
I
you
also,
have to do that?
they may ask you, I don't know if I assigned those problems, but there are problems on there like that, but I don't know if I assigned them. Okay, or could I restrict it to 0 to positive infinity?
Yes.
Yeah, I could take the left or the right individually, but not together to have that inverse to be a function as well. Okay, this is a what function? What kind of a function is this?
Square root.
No,
Cubic.
cubic. Shannon. Alright. Yes, I'll send her up like towards the end of the period. Is that okay? Okay. Okay, so it is a cubic because it's goes like this, right?
Yeah.
I expect you to know all those things. So, does it pass the vertical?
Yep.
Does it pass the horizontal?
Yeah.
Yes, meaning it is 1-to-1 and its inverse is also a function, correct? Okay, that was easy. Okay, now here's that reflection, just look at it. I made a table on both sides, you see the table? Are there domains and range swapped?
Yep. I like the table a lot.
Do you see the reflection now in that?
Yeah.
Yep. Okay,
What is going on here?
I have F and F inverse.
And then you have that line of
Here's
whatever
F.
you called it.
Here's F. Here's F inverse. Do you see the reflection across that Y equals X line?
Yeah.
Where did they hit? They hit right on that Y equals X line, didn't they?
Yeah.
Now do you see their values also being transposed? Domain became range, range became domain. Do you see that?
The table makes it a lot easier to
Do we need to
pick
write
up
any
on.
of that?
No, I just want you to visually see that.
So,
So-
how did they get all those points? Like, I know that.
They just graph the functions right here.
So that's an inverse and a function.
Like on a calculator? Or
Yeah, that's on a calculator, but you could do it yourself. They're linear lines. You could get all those points, couldn't you?
Yeah.
We should be able to. I picked numbers that were nice and you just go.
We are gonna have to prove.
Take your calculator out real quick and put these two input F1 or Y1, Y2, and then Y3 for words. No, in your Y equals, I think we're a little busy. I don't know exactly what for, but we've got plenty of time because I'm sure class will get extended because of math testing.
Oh,
So.
boo.
Katie?
Wait, so do we have to put -1 in there somewhere?
Yeah, how do we
No,
do that?
I want you guys, you just did this.
Wait.
Y1, Y2, Y3.
So you don't have to do anything with the -1.
No, I just put the equations.
Hold on.
Y1, Y2, Y3.
I'm confused real quick. Like,
Alright, what
I'm
do we
in
do
this
after
memory
that?
Zoom thing. I don't know how to go back.
Just hit Y
You can
equals.
still figure it out.
Okay.
Guys, you're not going to break it. And there's a quit button. Just hit quit if you don't know where you're at. It's one, you need this 1/2, and that green probably
We're
doesn't
putting all
have
those
to.
things that you circled in the calculator.
Okay, 1/2,
Y equals.
I got it.
okay, see it?
Just X on the third
Okay.
one.
Yes, just X on the third one.
Wait, I'm slow.
Ooh, I got a pretty little eye.
Is that -3 or -3?
That would be -3 because it's not at the beginning. Yes, then hit graph.
Then we use a fraction, the divide sign.
Where's your other calculator at?
I haven't got that.
Are you serious? Get batteries.
I have a question.
Yes.
Are we just graphing the 2x minus 3 and the 1/2
And
x plus
X.
3 and y equals x?
Yes.
Boom.
I
Okay.
got a question.
Yes.
To get a fraction, you put the division sign.
Yes. Sometimes when you put a fraction in there, you'll need to put a parenthesis around your fraction.
Yeah,
I'm
I
going to
did
tell you
that.
right now, your calculator follows order of operations. So if you don't put it in with parentheses, it's going to go straight across, doing the exponents, the parentheses, doing everything in the order it should. Does that make sense?
So what you're saying is I should put a parenthesis.
You might want to put parentheses around that 1/2.
I-
It shouldn't matter here, but there are times people are like, well, I just put it in there, and I'm like, well, it did this, this, and this. Well, that's not what I was supposed to do. Well, then put some parentheses to tell it.
So what's
just grabbed
what's an example of a time where you would have to definitely put
I
Nope, I
can't even make that up. I can't even make that up because it
just
just
always put parentheses around it?
if you have a numerator that's a quantity, you need to put parentheses around your numerator that's a quantity. Let's say if I had x plus 3 divided by 5, okay? That's x plus 3 quantity divided by 5, yes? If I put x plus 3 divided by 5 in my calculator, what's it going to do?
It's gonna take up.
No, it's not.
It's not.
My calculator is gonna divide 3 by 5, then add it to x. Because you didn't tell it to do that first. Okay? So that's what, I can't think of more because I was,
Yeah.
but if you've got numerators and denominators, you need to have parentheses around them. Okay, did everyone get this picture?
No.
Yes.
What'd you get?
That picture.
Did you put y equals x?
Get the put parentheses.
Oh.
Where do you get a third from?
Oh, because I typed the wrong thing in. I know.
You would definitely have to have a parentheses around the x plus 3. I don't think you have to do one half.
Now.
You got the picture now? Okay, so when their assignment says graph it and verify, this is what you're going to do. If you don't see that reflection, is it right? No. Okay. See it?
Oh my god. Yeah.
Do you see the reflection?
Kind of looks good.
It looks like a fish. A skinny fish.
It does.
No,
It's like diamond.
Yeah, and
Okay.
the cherry moment.
Okay, so here's the steps to finding an inverse. You need to write these down. These are the steps to finding an inverse. We verified, yes? We verified already?
Yeah.
We need to find them. So if x's and y's interchange when we have a result, correct? Wouldn't it make sense just to interchange the x and the y in the equation? That's what you do. First step, you interchange the x and the y, the domain and range. Solve for y. That's it. And then what we should always do, and we know we always do it, I can't wait, I'm trying, is what? Check your answer. And you know you all check your answer every time,
Yeah, we do, actually.
I don't think I
The
do.
back of the book.
right?
That's what I was.
So, we have check your answer by doing f inverse and, big and, right? F inverse at f. And what should they both equal? X. It looks like our test is going to be like Tuesday or
Oh, great.
Wednesday.
Wait, thank you for. I think I'm gonna be sick.
Thank you.
That's not good because then you're just putting it off, and then we're all moving on, and you have to make up a test, and
Ooh.
it is so much better just to take it when it's
If
like.
we have like a question on the test, will you help?
And we can't have notes, and we can't have choices.
We've
Oh,
never
I got my
he
calculator.
literally let us use
We
our
would-
calculators,
we've never
our
done
notes,
I
and we could
know.
ask him questions.
I know.
There would
So
only be like
there's not
20.
I think you should let us.
Well,
use
there
this
will.
one.
Okay, listen. If I ever have a test that has like graphing and non-graphing portions of it, we may do like a second day where it's graphing today, or when you finish those 2 pages, you raise your hand and I give you the other page and the calculator. There's no point in me giving you this and say, "Here, and use a calculator." What would be the point of me even teaching half of what we done?
Exactly.
No. We will not have a calculator on this test. And when you can ask me a question, I may say something and I may not. I check vocabulary in here because I'm going to say find the inverse. And you're going to say, how do I do that? I'm like, you need to know this, yes?
Wait, you
That's-
have vocab?
Well,
Yeah,
in the directions.
Oh.
Oh, I
how
thought you
you-
said-
like,
I
no,
thought you
it's
said you're gonna be
no,
like-
So you have to like.
No,
This is
my
injury.
I only check vocab in there. Now, there are times I'll have a test that like there's a bunch of equations, and there are equations I want you to know. So the first 8 problems of it may be I gave you the equation and you have to write the name. Does that make sense?
Yeah. Like
So I'll give you the equation and you have to tell me what equation it's for, and then guess what you have for the rest of the test?
A guy.
You have the equation. So.
yeah, if you know the right answer.
Yeah. But if I'm expecting you to know the equations, I've got to make you work out.
Are you expecting us to know equations for this test?
Yeah, the square root, cubic. Yeah,
I'm
know
expecting
those.
you to know those shapes, yes.
I don't know those.
Well, then you better start studying them. The
I
shapes are,
study for
guys,
that.
what's a parabola look like?
That.
Like this, yes? Okay, what's a cubic function look like? Looks like this, yes? What's an absolute value function look like? A V. What's a square root function look like? A square root. Look, think about it, guys. Doesn't it kind of look like a square root?
It's like zoom.
Yeah. Okay, and what's the
It's
other
a
one? Linear. What's a linear do?
All the equations for that.
Okay, so you need to learn to study a little bit for math tests, and we do have a review, and it will be Monday. Typically, I don't listen. Typically, I do not go over a review. I assign a review. We have the test the next day. We will this first time. I will assign the review, and you will have one day to ask questions. But that means you come in with every problem attempted, because if you come in and only have 2 problems done, is that going to do me any good or you any good? No. So you will get an extra day this time to ask questions, but that typically does not happen. Okay? So, you guys ready? You got this down?
Yeah.
Okay, so it says find the inverse. F of x equals 7x plus 4. And again, guys, these are inverses of each other, correct? So I could have given you the other equation and said it. What was your first step?
Interchange X and Y.
Interchange x and y. So what is f of x? Really? What's the same? Y,
Why?
isn't it? It's y.
So
So
we
it's
started
going to
Y.
be x equals 7y plus 4. That's your first step. Interchange x and y. Because why? Why do we do that?
To find the inverse, we have to switch them.
Right, because inverses switch what 2 things? What 2 things?
X and Y.
So
No,
that
what are
and
those
that
2
is
things?
the Y.
What are those?
Domain and
Domain and range. I'm making you use those nasty words. Domain and range. So now what do?
Set 0 and. Or
Nope.
Why not?
So,
Solve for y.
so you gotta subtract.
Because we still want an equation when we're done.
Then what do we put in 0 for x?
No, that's for x-intercepts and y-intercepts. I just
You
want to
x
solve for
minus-
y.
Take away minus subtract 4.
Subtract 4. And then what?
Divide by 7.
Divide by 7. So this is f and this is what? F inverse.
Wait, what?
This is f and this is f inverse.
What's the like Y?
Okay.
The Y at -1.
Well, this equaled y, and this y equals f inverse. This is f inverse of x, right here. This saying right there is f inverse of x. You don't say f to the negative first x. F inverse of x. So then what's my next step? Check. And how do I check?
Fill them in.
F of what?
X.
F inverse.
Oh.
And it better equal what?
X.
X. So I gotta plug this in to here, right?
Is that F times
That'd be 7 times
No, it's-
x minus
it's a
4
negative.
over 7.
What? Say. Oh, it's 7 times
X minus 4
x minus 4 over 7
plus 4.
plus 4. Well, these 7's reduced, yes?
So it'd be x minus 4 plus 4. Which
So be-
4's cancel out, which equals x.
How about they zero out?
Yeah.
And I get x.
Bam.
Okay, we did one way, now we gotta do what?
The other way.
You do it.
F inverse.
No, on your paper.
Hey, Kaylee, quit being rude.
Hey. Nice.
Bam.
Step are we doing now? The checking? Yes.
We started the checking. You need to finish it.
Oh, you are slow.
I think I did it.
That's on you.
I think I just did that.
Same.
X
But I'm
minus
still on
4
here.
over 7
I
equals
got it.
75. That's
You
not
do
what I
it,
did.
you leave it on there for everything.
Never mind.
Okay.
How did you do that? Because I put X minus 4 over 7. Okay.
Okay, so it says F inverse of F, yes? This is F inverse,
Yeah.
and there's X. So I put this in for X.
Yes.
So I have 7X plus 4, which is my F of X, minus 4 over 7. So, positive 4, negative 4 is 0. And now I have 7x over 7, which is just
X.
x.
excited, Chef.
Did you have a question, Evan?
Oh,
No. Okay.
Bam.
Now, if they are inverses, guys, have you noticed they fall apart pretty easily?
Yeah.
Yeah, I mean, there's some stuff we have to do, but it's not overly complicated if they're inverses of each other. It kind of just falls apart.
Yeah, that was my life. Same. Same.
We're all kind of living the same life.
Okay, are you guys ready?
No.
Yeah.
No, are you ready to go on?
No.
Yes. Okay, thank you.
Should I mess around and leave too?
Okay, so find the inverse.
I'll be back in like
Okay, what do I do to find the inverse of?
Oh, so we don't.
They don't want to
Okay.
make this class longer, Miss
Are you
Lee.
serious? What a joke.
They don't want to make this class longer.
No, I should have told them, please. Okay, what'd you do first?
You switch the
X and Y.
So it's gonna be x equals 5 minus 3y over 2. Yes?
Yeah.
Now I just have a basic algebra problem.
And you multiply by 2.
I multiply by 2.
Subtract 5.
Subtract 5 and divide by
3.
negative 3.
My mom saved me. Wait, so you multiplied x and that fraction by 2?
Yeah, you multiply both sides by 2. It reduces here.
Oh yeah, yesterday.
Okay, so that's my inverse.
Okay, so
Now I have to check it. Well, we don't have room to check it.
Well,
But you should check it.
So you
2x.
should always.
So you don't have to do
2x.
the other one?
Well, the other one, it's another problem. That's why I said we don't have a room. Okay,
Wait.
I want to do this one. Okay, so what do I do here?
switch y and x.
Okay, so I have x equals the square root of 2y minus 3. How do you undo a square root? Square it. So I square both sides. So I get x squared equals 2y minus 3. Yes? Add 3, divide by 2.
Yeah.
So y equals x squared plus 3 over 2.
Yeah,
I have
we're
a
really
question
gonna
on
get
this one.
good on this test.
Yes?
How
On
did you
the,
get
on
that?
that side, on the left side,
Uh-huh.
you have 2x equals 5 minus 3y. How did it end up becoming y equals? I thought we were finding x.
No, we're solving for y. We solve equations for y.
So when you do the
Right.
1 through
So-
27 on.
What did you like add
Yes.
everything over?
Yes, Wednesday.
So
What?
you added y.
I subtracted the 5 over
Okay.
and divided by the negative 3.
Okay.
Yes, Wednesday's homework, guys. I'll send it out to remind people.